Good morning? I think it's morning. Yes, it's morning because it's still before lunch. What am I thinking? It's barely morning. It's almost noon. At any rate, hope y'all are having a good day. I apologize I can't be with you. Family first. So, the first lesson of Chapter 2 is relatively simple, and I say that not because, I'm trying to insult your intelligence or anything, but because I believe the majority of you have experience with this, and if you do, it should be relatively review and not anything brand new. Okay, so let's take a look here. We're talking about solving one-step equations, and we're going to look at all four types of operations. Let's change it up here a little bit. I know that typically we would work through this packet together. Here's what I want you to do, so that we use our time efficiently and really get the experience of the video lesson in terms of, it's called flipped classroom, meaning normally what would happen is you would watch this video at home and then come back and do your quote homework at school. That way I'd be able to assist you and everything like that if you needed it. So that's kind of how we're going to treat this video lesson. So what I would like you to do is take as much time as you need, a couple minutes or so, and just complete 1 and 2 of the review. Pause the video while you're doing that, and then when you're done and confident and ready to resume, then you can unpause the video and continue. So go ahead and pause right now. Come back when you're done with 1 and 2. We're back. Here we are. Circle the multiplicative inverse of 1/2. That would be 2, because 1/2 times 2 equals positive 1. That's the multiplicative inverse is, also known as the reciprocal. Additive inverse is what number can I add to 1/2 to make it equal 0? That would be negative 1/2. For number 2, circle the multiplicative inverse. Again, a fancy way of saying reciprocal. So if it's negative 3, the reciprocal is also going to be negative, because then I have a negative times a negative to make a positive 1. And so those are the multiplicative inverses. Additive inverse, whatever I add to that to get 0, that's going to be positive 3 in this context. Moving on to vocabulary. Those of you who have any basketball knowledge will understand the word isolation. Isolation is typically an offensive set where one player has the ball and he is separate from the rest of the team. In other words, generally you get the ball either at the top of the key and everybody spreads out to let you go by yourself, dribble, drive to the basket, or maybe you have the ball on one side of the court and everybody is on the other side. Same concept. You dribble and try to beat your person one-on-one, and everybody else on the team is kind of hanging out waiting to see what's going to happen. So to isolate means, in math terms anyways, get the variable alone, basically. The variable one-on-one on one side of the equation and everything else on the other. So if I'm talking in terms of basketball, if I had a basketball court, hopefully this will help you if you're confused. All right, so if I'm isolating, generally I have five people on the court. So there's a person, and there's a person, and there's a person, and there's a person, and here's my x, my variable. X has the ball. If I'm going to isolate, let's pretend that the equal sign is the middle of the court. All right, so we're going to imaginary line right here in the middle. If I'm going to isolate the variable, it means I want the variable on one side of the court by himself with the ball, and all my teammates are going to go on the other side. So these two guys are going to have to go over there. That way I would have all 4 of my teammates over here and just me with the ball on the other side. And the way that we do move people across the equal sign is by using inverse operations. So I don't know if that helps in terms of a visual picture. Hopefully you appreciate the basketball reference, if nothing else. And that being said, we can kind of move on. I'm going to need a bigger eraser than that, aren't I? So at any rate, what we're looking at here is the word isolate. It does have different forms, and we're going to kind of digest the different forms here. So again, isolate the variable means get the variable alone or by itself. Isolation and isolated are the 2 other forms of the word that we're going to use. So to make sure that we have an understanding of the vocabulary, we are going to concentrate on problem number 3, which is filling in these 3 blanks here with the correct form of isolate. And I would also like you to try this by yourself and pause the video while you're working and then resume when you're ready to check your answers. So what we've done here is filled in the blanks. A very ill patient was placed in isolation away from the other patients. In order to isolate a variable, you may need to perform mathematical operations, and a person living in a small island felt isolated from the rest of the world. Hopefully you can read that. Apologize, it's pretty difficult, believe it or not, to write with the pad here using 2 fingers. So at any rate, circle the equations that show the variable isolated. So what I'm looking for is variable by itself on one side of the equal sign and everything else on the other side. Take a couple of seconds and do that. I'll hang out this time and wait for you. So I would have circled the second equation and the fourth equation. It does not matter which side of the equal sign the variable is on or isolated. It just matters that variable on one side, everything else on the other. So those are the 2 that are isolated. Moving on. Properties. So we've done some of these properties before. We're talking specifically addition property and subtraction property of equality, meaning for any real numbers a, b, and c, if a equals b, then a plus c equals b plus c. In other words, if the first 2 values are equal originally, then if I add something to one side and I add the same thing to the other side, the values should still be equal. The example we have is this equation, n minus 7 equals 12. So I'm sure you've learned at this point, I undo, so to speak, the subtraction with addition, meaning I'm going to go ahead and add 7 to both sides of the equation. It does not change the equality, does not change the fact that they're equal. What it does change is the appearance. Kind of like if I'm wearing layers of clothing to school, and it starts out, it's a chilly morning, and it's like 55 degrees, and I'm waiting for the bus, and maybe I have a hoodie on. And then I get to school and it starts to warm up, or it's warm in the building, I can take my hoodie off and I have my t-shirt on underneath. I didn't change who I am, right? I just changed my appearance. I changed what I look like. So same idea. I'm either adding or subtracting clothing from both sides of the equal sign, if that makes sense. Subtraction property, I can do the same thing with subtraction. For any real numbers a, b, and c, if a equals b, that means a and b are the same, then a minus c equals b minus c. So again, subtracting the same amount from both sides of the equation should not change the fact that they're equal. And again, that's going to be a way to undo addition. If I subtract 8 from the left, that means I need to subtract it from the right in order to maintain equality. Again, it does not change the fact that both sides of the equal sign are equal, but it will change what they look like. Alright, so I'm sure you've seen that before. It's the basic premise of algebraic equations in terms of solving them. I do inverse operations. So let's take a look at some examples, shall we? First of all, I know this is really elementary to some extent, so we'll try to move as efficiently through it as we can. What is the solution of y plus 2 equals negative 6? Check your answer. So, first of all, these are like mental questions, mental steps that you're going through. I apologize if it seems too slow for you or you already have it. It's never a bad thing to review because it can always help you avoid the simple or silly mistakes that sometimes we do, or we'll get an incorrect solution because we did the wrong operation. You want to try to avoid those. So the equation y plus 2 shows addition. It's telling me to underline, so I guess I'm going to go ahead and do that. The inverse of that operation, in other words addition, the inverse of addition is subtraction. So that means I should be subtracting on both sides. Use the justifications to solve. Okay, so write the original equation, subtract 2 from each side. Why am I subtracting 2? Okay, because I want to subtract whatever is with the variable. So right now I've got y and 2 on the same side of the court. Y wants to isolate, so he's going to tell 2, hey, get lost, get over on the other side, clear out, get over there. The way that I do that is by subtracting. Okay, so I'm going to go ahead and subtract 2 from both sides. This is where I need to be careful with signs. I've got negative 6 minus 2, which is the same thing as negative 6 plus negative 2, moving further to the left. So my solution should be y equals negative 8. That is its simplified solution. Okay? And then we're going to check our answer by substituting into the original. So I'm going to take my negative 8, I'm going to plug it in right here. This is really more of a mental step than anything else. So if I start at negative 8 and I add 2, I'm moving 2 to the right, which does take me to negative 6 on the number line. Did it work? Yes, it did. And I'm finished. That means my solution is y equals negative 8. Okay, moving on. If you need to pause, rewind, by the way, look at that again. Go ahead. Otherwise, again, we're going to kind of move pretty efficiently here. So this is the multiplication and division properties of equality. Same idea. If a and b start out being equal, and I multiply the same value to both sides, the equation is still equal. So over here, I've got x divided by 5 equals 10. If I multiply 5 on the left, that means I should multiply 5 on the right to maintain the equality. That's what the multiplication property of equality states. I can do the same thing with division as long as the number I'm dividing by is not 0. Hopefully you've learned by now that if I divide by 0, I'm going to get an error because I can't divide something into 0 pieces. That doesn't compute, does not make sense. So again, if I divide the left by c, that means I should be dividing the right by c. That's not going to change the fact that both sides are equal. Example, dividing the left by 6, which means divide the right by 6. I didn't change the fact that they're equal. It is going to change what it looks like, though. Okay. Hopefully that's self-explanatory. Let us move on. What is the solution of 10 equals 15x? Check your answer. All right, so a couple of things here. First of all, the variables on the right, which is really not a huge issue. You can go ahead, by the way, this is completely equivalent. I used to do this when I was learning it until I understood that it really didn't matter which side I had the variable on, but if you need to rewrite it like that because it's visually more appealing, please go ahead and do so. That's perfectly fine. Nothing wrong with that at all. So the equation is solved. Write a justification for each step. Okay, so my justification is simply that I copied the equation right here, I believe, is what they're looking for. Oh my goodness, excuse me for yawning. It's been a long day. Where was I? Oh. So I'm copying the equation. I don't really need to write anything in here. But I do notice that what is happening. This is multiplication. So I notice that multiplication is taking place, right? So maybe I want to say something about that this is multiplication. So that means I'm going to do the inverse. I'm going to divide both sides by 15. Why not 10? Because 10 is not the number with the variable. I'm always going to do the inverse operation to whatever number is with the variable. In this case, 15. So I'm going to inverse I know that's tough to read, that's why I'm saying it. Inverse of multiplication, which is division, obviously. Dividing both sides by 15. That gives me 15 divided by 15 cancels. That gives me x over here. 10 over 15 is a fraction. I can divide the top and bottom by 5 and get the solution x equals 2/3. So this is simplified. Simplify. Check your answer. 10 equals 15 times 2/3, I'm assuming. 15 times 2 is 30, divided by 3 is 10. Ta-da, we did it. Awesome. Alright, so again, this is a really elementary way of looking at it. These are more mental steps than anything else. I'm pretty confident that all of you have the ability to do this without writing down every single step. So the good thing about knowing the steps, though, is when you get to a problem that is a little bit more complicated, then you know what to do. Let's move on. Solving the equation using multiplication. Alright, so there's a couple different ways to look at this. What is the solution of 19 equals r over 3? So r over 3 is a division problem. You'll also notice that the variable's on the right side of the equal sign, which, if I wanted to, I could rewrite it. I know some of us, like me, are OCD. We need to have things just right, a certain way. Can't have that variable on the left, Mr. Hanson. Doesn't look right to me. That's fine. Then flip the whole thing around. Underline the correct word or number to complete the sentence. To isolate the variable, what should I do? Well, again, that kind of looks like a fraction, doesn't it? A fraction indicates division, which means I should multiply. Question is, what do I multiply by? Well, the rule was always do the inverse of what is with the variable. So the 3 is with the variable, which means I'm going to multiply each side by 3. When I do that, here's what it looks like. Times 3 over here, times 3 over here. This goes away, obviously. It cancels. I'm left with r equals 19 times 3, which is 57. R equals 57. Okay. Hopefully that, is, again, you've seen this before. Try not to drag it out as much as I can. All right. Solving an equation using reciprocals is the next example. And you generally do this when you have a fraction that does not have a numerator of 1. So if I look at this, I notice that it says 12 equals 3/4 x. So instead of it being like x over 4, now it's 3/4 x, which means that I have a fraction without a a numerator of 1. The top number is not 1. So I'm going to have to utilize a slightly different strategy. The inverse operation is the same, but what I'm going to do is use reciprocals now. So to solve the equation, I'm going to multiply. All right, so 3/4 technically is division, even though it's 3/4 times x, it's still division. I'm going to multiply both sides by the reciprocal of 3/4. All right. So the reciprocal of 3/4, again, reciprocal is a fancy way of saying multiplicative inverse, and that means flip them over. So I'm going to be using 4 over 3. Use the reciprocal to solve. Okay, so here's what it looks like. I'm going to purposely not flip these around and leave the 3/4 x on the right side for this particular problem. So here's what I got. I've got 4/3 times 12 on the left, and I've got 4/3 times 3/4 x. Let's see what happens. Okay, over here, there's a bunch of different ways to multiply this. You can put the whole number over 1, cross divide, blah, 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 or you can just do 12 times 4 is 48, divided by 3 is 16. Over here, these reciprocals, the reason I'm multiplying by the reciprocal is to cancel the coefficient. 4 divided by 4 is 1, 3 divided by 3 is 1. I'm left with just old plain x, which is what my solution should be, x equals 16. Question is, does it work? Well, let's throw 16 in here. I think it does. 16 times 3 is 48, divided by 4 equals 12. So, do they match up? They most certainly do. They most certainly do. Alright, so that is how we address fraction coefficients with variables. Alright, last page. Problem 6, using a one-step equation as a model. So again, always the important thing here is, can I apply this in the context of a word problem? An online DVD rental company offers gift certificates that you can use to purchase rental plans. Does anybody do gift certificates anywhere? You have a gift certificate for $30. Awesome. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? Alright, so you probably already did the mental math, but we'll walk our way through it anyways. Complete the model to solve the problem. So the cost per month times the number of months would be the amount of the gift certificate. So I'm going to go ahead and let M, Mike, equal the number of months, because that's what I don't know, right? It says right here how many months. So let M equal number of months. That's the unknown. Number of months. It's really hard to write with that. Yes, that's an O. At any rate, okay, so cost per month, it tells me that information, doesn't it? $5 per month. So I'm going to toss that in here. And the amount of the gift certificate, it tells me that it's 30 bucks. I'm going to toss that in here. And the only thing missing is the number of months, which is M. So I'm going to toss that in there. Solve the equation to find the number of months you can purchase. So I got 5M equals 30. You probably already did it mentally, like I said earlier. You're going to, the technique would be to divide both sides by 5 because 5M means 5 times M. And just because I ran out of room, I'm going to write off to the side. M equals 6 months. Okay, so I can purchase 6 months with the $30 gift certificate. Pretty basic example. Okay, you'll see plenty of more difficult ones, I think, as you go along, but definitely try to start you with an easier one. So, lesson check. I tell you what, I'll give you time to work independently here. Take a couple minutes. Please pause the video and answer questions 20 and 21. Don't forget to write in complete sentences and explain. And when you're ready, unpause and come back to check. Alright, 20, not a trick question. I see an addition sign right there, so I see addition. It shows addition. So then I would use the inverse of that, which is the subtraction property of equality. I would subtract 3 from both sides. So subtraction property of equality would solve the problem because I need to subtract on both sides. Would be a good explanation. Okay? Alright, so check off the vocabulary words that you understand. A lot of these are from previous, but we'll go ahead and kind of check them off as we go at any rate, just because. Equivalent equations. So those are two equations that are equal. Equivalent and equal mean the same thing. Isolate. Hopefully we know what that means. Get the variable by itself. Inverse operations are the two operations that undo each other. Addition and subtraction undo each other. Multiplication and division undo each other. Addition property depends. Like we talked about the property of equality, meaning I add the opposite to get 0. Subtraction property, I subtract the opposite to get 0. Multiplication property, I multiply the opposite to get 1. And division property, I divide the opposite to get 1. Please rate yourself. 0, don't have a clue. 10, golden. The great news about this video is you can review it as many times as you need or in different areas. If you, like, here's the thing, if you're anything less than a 10 right now, I would go back and watch a couple of things that you missed another time just to make sure that you have clarification. That's the great part about this video lesson is, like, I don't have to repeat myself. I do the video once and you watch it. You need to see it again, then you watch it again. I don't have to teach it to you a second time. That might sound kind of selfish on my part, but I think it's more efficient for you, especially when I'm not there. At any rate, you are responsible for page 85. I'm going to give you some time in class right now to do it. Page 85. And we're going to do 10 to 48, just the evens. I know it's Friday. Okay. I know typically I don't give you homework over the weekend, so that means you better finish this up before you go, because I'm going to be checking it on Monday when I get back. So page 85, 10 through 48, whoops, just the evens only. Okay. If you're doing it on your, in your notebook, great. On a separate sheet of paper, great. Please show your work. In other words, I want to see the inverse operation. Okay. That should not be an unreasonable request. I realize that a lot of us can do this work mentally. That's great. But again, you show your work. Completely eliminates the potential for silly mistakes, and it shows me that you really know what you're doing. So please attack that. Have an awesome rest of your day. Have a great weekend, and I'll see you on Monday.